Hello, in this video we're going to go through the answers to the problems relating to significant figures, and then in a different video we'll go through arriving at the answers to the problems involving scientific notation. So quickly here, how many significant figures should be in the answer 973 plus 56? Well, the first thing we'll notice is that this number 973 itself has three significant figures. 56 has two significant figures. Now, a lot of students make this mistake of trying to simplify things and saying, oh, well, I'm just always going to choose the least number of sig figs, so I'm going to say 2. And it doesn't work like that. So, in fact, 973 plus 56, we'd have 9, 12, 1029, and all four of these numbers are significant in the answer. When we deal with addition and subtraction, we always look at the decimal places that we have in common. We know there's a 3 here for sure. We know that there is a 6 here for sure. So we know that that 9 is legitimate. So we're allowed that spot. 7 and 5 is 12. We know that 2 and 9 plus 1 is 10. So we know all four of those. We'll see other examples where we don't have some decimal places that we don't know and how to treat that. But when we try to simplify rules just to make things easy on ourselves, that's often not the correct approach to take. So when we deal with addition and subtraction, we look at the decimal places that we know, and we round the number to the last decimal place that we know. In this case, the 3 and the 6 are in common in terms of their decimal places. Next question, how many significant figures are in 0.007500? Well, if you remember, the rule for sig figs is to look at the first non-zero digit and count it. The first non-zero digit to the left is 7. The 5 is therefore also significant. Trailing zeros, zeros that come after the first significant digits, are themselves also significant. We are communicating that we know this was not 7543, it was 7500. Okay. So this particular number has 4 sig figs in it. What decimal place should these two numbers be rounded when we add them together? Well, here I would advocate lining them up because we have to look at decimal places. So what we're really saying here is I am certain that this number is 0.0651, and I do not have a digit here. This is totally a question. The 1 is uncertain, but this one is absolutely missing. So it makes no sense when I add these things to me to report 8 plus something here because I don't know what I would be adding to that 8. So we're not really going to consider that decimal place anymore. The first decimal place where we have uncertainty is, in this case, the 4th decimal place over. When we do add, this is an 8, this is 6, that's a 0, 6902, so the decimal's there. So now we have 0.20068. Now we have to round. We said that this is the decimal place that we're going to report because it's the first decimal place where we know all of the numbers. We don't know a number here that we're adding to 8, so we're going to have to round. So this rounds to 0.2007, and we would be reporting 4 significant figures, and we'd be at the 4th decimal place. So again, when we add and subtract, we're looking at decimal places. When we multiply and divide, it's a different rule. So we just have to keep those two things apart. It's only 2 rules. So give the answer to the following. So we have 213.3642, 17.54, 32978. Okay. Notice in all of these cases, I'm not just using a calculator to try to do this. I think it's easiest to see if we align vertically, and it's pretty clear that we don't know any decimals here. We don't know what we're adding the 3, the 6, and the 4 to down here. So there's no way we can possibly think about reporting a number down there. So right now, we've identified for ourselves that we're not going to report anything after the decimal point. However, to the left of the decimal point, in the ones place, we do know the 8, we do know the 7, and we do know the 3, and we know that those add up to 18, 7, 8, 9, 10, 9, 10, 11, 12. So we have 3, 3, 2, 0, 8. And then if we did add these, this would be 2, 6, 10, 9. So we would guess that if we would add something here, this would make it greater than 9. So we round up on the basis of that last digit being a 9. So we round the 8 up to itself being a 9, but we would only report those 5 decimal places. So our number would have 5 significant figures, but no decimal points, even though for this number we knew 4 decimal points, 4 decimal places. For this number, we don't know any. So imagine the scenario that I said 27 plus a number that's in my head. You wouldn't be able to report the final answer because I'm not giving you any decimal places. But if I said 27.9 plus 3 point something, but I'm not going to tell you the point something, you would at least know 27 and 3 would be 30, and you already have the 0.9 there, so you know it's going to be more than the 30.9 that you already are certain of. So you'd be pretty comfortable rounding that up to 31, but you also know it's not going to be more than 32 because I've already told you the 3, right? So that rule makes, I think, a great deal of sense if we stop and think about it. And I just think about it, do I know these numbers? And if the answer is no, then I can't possibly add something to it and know it any better than I originally knew the first numbers. Next one, how many sig figs do each of the following have? Well, again, we identify the first non-zero digit, the first digit that isn't 0. In this case, that's 1. And then we have 4 digits that come after. Zeros that are sandwiched between other numbers are, in fact, themselves significant. We're saying this is 10.5, not 11.5, or not 9.55. So that 0 carries information with it. So this would have 4 sig figs. This one, the initial zeros are simply placeholders. We could rewrite this as 5.002 times 10 to the minus 2. And therefore, this only has 4 significant figures. This one, the 1 is the first non-zero digit of significance. And then we have 3 trailing zeros, all of which are significant. I am saying I know that this is 0.1, and if I put this on a balance, let's say, I know it was 0.10 grams, and then the next digit was 0, and the next digit was 0 on the balance. It wasn't 0.1108, it was 0.1000 on the balance. So this has 4 sig figs, and then the last one also has 4 sig figs, again with the trailing 0, but that trailing 0 is significant. So initial zeros that are placeholders and decimal markers, not significant, trailing zeros, significant. Now the next one, we've got 0.15. This has how many sig figs in it? This has 2 sig figs. That initial 0 is not significant. We could rewrite this as 1.5 times 10 to the negative 1. So 2 sig figs. This has 6 sig figs. That has 5 sig figs. And this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sig figs. Okay. Now, the rule for multiplication and division is different than the rule for addition and subtraction. In addition and subtraction, we look at the last decimal place that is known in common. In multiplication and division, we say we're going to round the answer to the least number of significant figures of all of these values. So the least number of significant figures here is 2. So when we take our calculator and multiply this by this, by this, by this, by this, we get 6,134.36574. If I've done things correctly, that's what our calculator might show us. But now we say, hey, look, we can only limit this to 2 sig figs, because that's all we know here. And when we multiply, we can't be any more certain of the answer than we were of the number of sig figs there. So we would round this to 6,100. So that would be one way to write it without a decimal place. If we put a decimal place there, so if we wrote it like that, then these zeros become significant because that decimal place is trying to telegraph to the viewer that you do in fact know that that's zero. In the absence, you're saying, hey, I really didn't know that number at all. I have no guess at it. Or better to write this as 6.1 times 10 to the third. Oops, sorry. 6.1 times 10 to the third, where you take away the ambiguity and you are simply reporting two sig figs and then using scientific notation to imply where the decimal would be, the order of magnitude being 6,000 in this case. So after rounding, this number would have two sig figs. We could think of a whole host of questions. 132 times 0.00896. Let me just take out a calculator real quick and do that. Well, I can't seem to find my calculator right now, but let me add a few more digits here too. If we do a few more digits like that, you can go ahead and do the multiplication. This would be 3 sig figs. This has 1, 2, 3, 4, 5, 6 sig figs. You would want to limit your answer to 3 significant figures. And in fact, I just found my calculator on the floor, so I'll go ahead and do this real quick. 132 times 0.008965778. And you get 1.18348. And if we round to 3 sig figs, we would just take the first 3, the 3 rounds down, so we would report this as 1.18. Okay. Now notice here, this is a different rule. How many decimal places do we have in 132? We don't have any decimal places here. How many decimal places do we have in this number? Well, we have scads of decimal places here. Notice in our answer, we get 2 decimal places. Even though we don't know decimal places here, when we multiply, we are allowed those decimal places versus in addition and subtraction, when we don't know them, we can't report them. And if you take quantitative analysis, my sophomore, junior level course, the next course in the chemistry sequence, in addition to organic chemistry, we actually go through the rule of why this is, and it has to do with uncertainty and how well we know numbers and what we do when the real rule for propagating uncertainty when we work with numbers. So it's pretty cool. There are reasons for this. This is not arbitrary. That's what I hope to convince you of, is without showing you the details, there really are rules behind this. So it seems confusing that in this case, when we multiply, we do actually get some decimal places, even though we didn't have any here. But just remember, it's a different rule for multiplication and division than it is for addition and subtraction. You have 2 rules to learn. You can learn 2 rules. It's like learning a sport. You learn hundreds of rules when you learn a sport. This is no different. Last problem. This is where we have a mixed calculation. Whenever we do mixed calculations, we follow order of operations for rounding, just like we do for actually doing the math. So we're going to first deal with the numerator because there's subtraction in the numerator. We're going to then deal with the denominator separately, figure out how many decimal places or how many sig figs we should have in the numerator and the denominator, and then deal with the division of those two and see what we have to do with that. So in the first case, in the numerator, we have 984.4 minus 981.4. That becomes 3.0. So notice our numerator now only has how many sig figs? It only has 2. How many sig figs are in that number and in that number? Yeah, there's 4 sig figs in both. But when we subtract, because the 980 and the 980 are of the same magnitude, they subtract out and we lose significant figures. Okay? And that can happen when we subtract numbers from one another. And it happened here. So our numerator now has 2 sig figs. And then 131.4 minus 49.9, we'd have 15, so that becomes a 6. 10, I'm sorry, 14, so that is a 5. That's 0, 10, 2, 12, 81.5 it looks like. So we would have 3.0 divided by 81.5. Here we have a decimal, first decimal place. We are allowed that 5. And then we see that we do lose 1 sig fig, and that 131 has 4 significant figures. This has 3 significant figures. Our answer has 3, not because this has 3, but because of the rules of using the decimal place has limited us to 3. And now we take 3 divided by 81.5. If you type that into a calculator, you get that. But then we have to go back to the rule and say, well, how many sig figs are we allowed? We only have 2 sig figs in the numerator. So when we divide or multiply, now we look at the least number of sig figs we've got in either of the numbers we're multiplying or dividing. And then in this case, we have 2, so we're going to have to round this to the first 2 significant figures, the first 2 non-zero digits. The 8 would make that round up to 0.037. I guarantee that if you just take this compilation of numbers and cram it into your calculator and try to do this without going through these things separately, you will not arrive, or it's very unlikely, I should say, that you will arrive at the right number of significant figures. So much of what I'm trying to impress upon you is that in these courses, we're less concerned about the actual numeric value. So in high school, all of your classes might have been, hey, great, you got the right answer, that's all we're asking for. Here, we expect you to be able to use your calculator. Now we have to learn how to communicate chemical and scientific information. So if I walk up to somebody at a conference and I say, hey, I measured something and it's 0.037 grams, I am communicating to them how well I know that number. By only giving them 2 sig figs, I am implying something about the accuracy and the precision about which I know that number. If I walk up to them and I said, I know that I had 0.037596 grams, then I'm conveying something where I know a lot more information. I know it a lot more accurately. So sig figs are not meant to be oppressive. They are meant to communicate. And we're familiar with this on an everyday basis. If I say, how many people are in your class? And you say, well, about 30, right? You're giving me 1 sig fig, 30. That 3 is the only significant one because you're not giving me a decimal point. Versus if I ask you how many people are in your class and you say 37, now you've given me 2 sig figs, and I know that answer is to more decimal places or to more places, and I know that you've made that count accurately. So sig figs are really a way of communicating how well we know a number. So it's really important. That'll be the end of this video on significant figures. In the next video, I will take up the problems dealing with exponents and scientific notation. Thank you for watching. Hope this was helpful.